Ottawa as well. So it's my pleasure to be here. Thanks for invite. So we will start with a little Slido poll. So I see right now we have 16 votes, and maybe what I will start doing, I will start sharing the screen so we can see how it goes. I see that we have about 45 people attending the meeting. So I know it takes a little bit of time and effort for everyone to get into the groove. And in meanwhile, I will be introducing you to the topic, which I will be presenting today. So I will be talking about data engineering. And in fact, I have to tell you, this is not a rocket science. This is not about like data science, like all what we want to do the most, you know, something exciting, something like really breakthrough, very scientifically challenging. Scientifically, maybe it's not challenging, but in terms of coding, it is. In terms of maintaining the code, in terms of developing robust codes which are reusable, scalable, so that I write something and you can use it. And in fact, or vice versa. In fact, in global community, there are so many people who are building the codes already and who have probably much more skill maybe than all of us together in some areas, right? So it's just a matter of knowing how to tap into the pool of knowledge which is available to all of us. So that's why I'm using this opportunity not only to talk about data engineering, what is data engineering, what is data linking and cleaning the data, many other things we have to do, but also to talk about how can we collectively, working from our remote locations, to work together, to help each other and to have fun and to be more efficient in what we're doing. So maybe we'll go to the next question. I see we have, oh, actually, no, I see we have more and more people joining. So we have 23 people right now. So now I have also to say that this presentation is a follow-up on the presentation I made last month at the GC Data Conference on the 23rd of February, I think. So instead of repeating the same presentation, I decided to invite you to go to watch the recording of this presentation because the recording of that presentation was just posted by the conference organizers. I will provide the link to this conference and you can watch it. There is a demo there about data engineering and Shiny, but today we'll go to talk about other things and about building a community. So, and the first question is really just to see R or Python. Okay, we see right now, and I think this is where I can start sharing the screen with you. Let me just try to do it. Okay. We'll move to the next question just right now. It's a little harder, but it's a good one. In fact, I'm taking it from the this talent, what is called talent management, which Stats Canada, I think, it's a nice project which Stats Canada are doing right now. It's and actually I've attended this session at GC Data Conference, and I found it very good because again, it's how about to leverage each other's skills, and we're coming from different backgrounds and we have different levels. So let's see where we are here. And while you're answering the question, I will start sharing my screen. Now, in this question, we divide people into technical and non-technical. But technical really means people who actually have hands-on tasks to do manipulation, like hands-on manipulation, cleaning, working with data. Because we know that many of our colleagues actually do not manipulate data themselves, but they are more in policy, in stewardship, ATIP, for example. So these are also very, very important, of course, positions. But really, This presentation is about data manipulation, data engineering. So it would be nice to see who is coming from which background. Okay. All right. Now, John, do you see my screen yet?
No, not yet.
Okay, let me try it again. Okay.
Yep, it's working now.
Okay, so I guess you see the results of the poll. So we have 19 people answered the question, right? So, okay, and I will just keep talking about introducing you to the topic of my presentation here. Now, while you are answering, I will open my presentation. Here, so you can see it as well, right? So we will just start with the presentation here. So we're doing right now a roundtable, and what we'll be talking about today is we'll talk about data problems which many of us encounter. We'll talk about the vision on how to resolve those problems collectively. And we'll talk about methodological approach to data engineering. Then we'll talk about the 4 pillars of our trade, which I call algorithms, then R Markdown, and Shining. And we'll use a few use cases. And next steps, introducing essentially GC Collab user R group and GC Code R for GC groups. Okay. Now you see the results here. We'll go to the next question. So you will see the link to the conference if you have not sent it yet, or if you have not seen it yet. You'll see it in user R group. Okay. All right. So in meantime, I also just would like to provide a little background about myself and why I'm so excited about this topic of data engineering, because really I'm coming from a computer science background. So I did my PhD in computer science from University of Alberta, and in fact, in computer science, we've done a lot of data manipulation, of course. It was not called data science at that time, but it was all about really taking the images. My PhD was about autonomous robot navigation using video data. So you can imagine video images, arrays have been processed and then eventually converted to a signal to a robot where to move. Then I worked at NRC, and there we built some video recognition technologies to move the cursor. So the face would be tracked, and again, you have an array of numbers and you need to convert it to some actions for the mouse cursor. So these are examples of data engineering, but coming from computer science background. Now, let's see what is your data engineering challenge, or how much time do you spend yourself preparing data. So for time being, I'm not calling it data engineering, I'm calling it data preparation. And this includes everything you have to do before you actually start applying your nice machine learning or AI tools, any packages to do this high level advanced, what would be called advanced analysis, right? So I will click myself here. I would say in between 75 and probably 75 for myself. So I will also submit my question here. So that's a very important question because it really sets the foundation and the raison d'être. Pourquoi on a cette discours ici à propos de ce problème de génie de données. So, and here, again, I would like to refer people to watch some of those presentations at GC Data Conference. In fact, the very first presentation was from Stats Canada. Let me just, what was his name? He was talking about the, I guess it's Chief Information Officer from Stats Canada was talking about how much time it takes for us to do this pre-processing before we actually get the job done. And he was saying 90%. I was thinking maybe about 80%. Yes, so that's how much we spend, right? Now, let's see what type of data preparation challenge bothers you the most, or where you spend most of your time. So this is the open-end question. It's probably the toughest question. So you may come up with a few challenges which you are working on right now. So for example, I'll just write merging noisy data. So we'll see if we can see the results here. What is it? I have to admit, actually, I'm not very proficient with the slider, so I'm using it actually for the first time myself. But I guess later we will share with you the results. Okay, now, actually, I guess you cannot see the results, but I see them here. So this is very interesting, right? So we have processing text data. We have schema changes over time. This is it was one of the questions I was going to put in the poll. How often your schema changes? You know, if your data doesn't change at all for the entire duration of your project, that's quite an easy life you have, I would say. But if you, let's say, your data, your schema, your variable names change, or something changes in the data, it becomes much more difficult to apply the same algorithm. You do need to think algorithmically how to make it so it's agnostic to name of the variable, agnostic to where this variable could be or how it could be represented. You know, again, we'll be talking about data cleaning. So using abbreviations, very common, right? Using different names for the same, let's say, company or the same person. We'll be talking about that. Formatting, yes, of course, formatting, very important. Inconsistency. So I really like this tool. Like Slider really shows us that many of us know how to answer this question. Formatting, yeah, even date, just the date. I was told that just extracting the date and the timestamp is quite a pain for many people because the date can be spelled in so many different ways. Now, okay, gaps, like we have empty or we have blanks. Now we have, of course, inconsistent data. We have volume, of course, volume. Now this is a big one. This is a big one because here I will say a joke, which I was planning to say at slide number 10, but the joke is about computer science. That was the first joke I've heard when I just started computer science in my first year back in Moscow, and then I used it when I was teaching Introduction to Computer Science at University of Alberta to humanitarian science, to social science. The joke is the following: how many numbers do computer scientists know or use? And the answer is only 3 numbers: 1, 2, and infinity. Because if you need to do anything more than twice, You develop the algorithm and you apply it as many times as you wish. So this is where really the data engineering, or now we're talking about software engineering, or we're talking about algorithms, becomes the key concept. And this is what I think distinguishes computer scientists from statisticians or maybe mathematicians. Of course, this is a very root distinction because, of course, everyone uses skills from data science and computer science and statistics, but algorithms is critical. It's vital when you have big volumes, when you have inconsistent data. You have to automate the process. You don't want to do it all yourself, all the cleaning, all these many different tasks. You want computer to do the job for you, right? So, and that's why automation or algorithm becomes, to my understanding, as a person coming to data science from computer science background, algorithms is the main pillar of robust, scalable data science. So you need to define your program or your code or your project in terms of the algorithm. So we will look into all those problems later. In fact, myself also, I am very much interested to see what is in your mind. And now the next question is, how do you find the solution to your problem? Do you use, in particular, do you use Stack Overflow or Stack Exchange? So I will answer this myself. Yes, I seek for answers there, and also I ask questions there, and also I provide answers there. When I find the answer eventually to my own question, I put it there. And this is the easiest and the best way for me to keep my knowledge base. Because next time, 2 years later, or even 5 years later, in fact, I will just go back to my page on Stack Overflow, and I will find by tag, question about time series or geocoding. So, and in fact, I even have prepared some of these here. So you will see on my screen, that's my page on Stack Overflow. And I've been asking plenty of questions over the last 5 years because I'm learning. In fact, I started learning R in 2000 after my parental leave, 2013. I switched from biometrics to a more general data science. And I started learning R. I was using only C++ and Visual C++. This is what I was using for 20 years before that. And now I started learning R, and I had many questions, and I started asking those questions, and then I was answering them. So you will see there are questions about very good question, or very simple question: how to replace a character in RString, because this is what you have to do when you need to clean your postal code. In many cases, there will be, instead of 1, there will be L, for example, right? And you just need to replace L with 1. So how do you do it? Here you go, you ask the question, and then you got the answer. And look how many answers they got, and even some comparison on performance. So I invite you to do that, not only to seek for answers, but also ask questions and answer them sometimes when you find the answers. So now the next one. Do you use GitHub or GitLab? So that's the next main resource for us coding, doing data science. We don't want to reinvent the wheels. In fact, we understand that, like myself, I'm doing only for 6 years with R, and it's not the main part of my business just doing R coding. And I know there are organizations, or let's say RStudio folks, they're so efficient, they're so good, and they're actually they provide very good solutions, and they open their solutions. That's very important. They open their solutions, so you will be able to find, for example, today we'll be talking about topic modeling. You will find it all there. It's all available with codes, with description, with everything in GitLab. So I will quickly go there to answer myself. So yes, I find useful codes, and yes, I save my own code. Now, you probably know that now we have GC code. GC Code is a service or portal provided and maintained by Shared Services Canada, and it's a very good one. It's not only, by the way, it's not only for the codes. You don't need to think about it only to archive and maintain your Python or R. It's for knowledge base. It's just for knowledge base to invite other people to contribute to your knowledge base. So I'm sharing you a knowledge base which we have started creating. GC Code R for GC. In fact, we open it to everyone, and you will be able to go there, and you would see some files, for example, like GC Code 101. So you don't know how to commit your code from RStudio, and we'll talk about RStudio later. It's very easy right now. You can do it, and in fact, I know many people had those challenges, and we have documented all of the questions here and the answers. So just a good example, you have a question, don't hesitate to ask it here or in Stack Overflow. And now we will be talking about, creating a larger community. So we'll be talking about this use R. I just created it 2 weeks ago following the workshop because there was so much interest and in fact request, let's do something about it. Let's just bring together people working in R and help each other. And we'll spend some time on that. So let's go to the next question. Now, let's go to this one, because now we go to the next pillar, which which I will be talking about today, which is reporting or scientific reporting or documenting the code. So algorithm is just one pillar, but if you develop algorithm and you do not do your literature search, as a person coming from, let's say, research background, we know that you need always to do literature review or background first sort of analysis, what has been done in your area. And normally you would create a file. It could be Word, it could be LaTeX, or now we have our Markdown, and you just keep pasting there everything you find useful. And for example, you're doing this topic modeling I will be talking today about, or data linking, linking of noisy data. So you can create R Markdown and you can just put all the information you find there useful. You go to GitHub, excellent, found link, put it there. You found something in Stack Overflow, put it there. And at the same time, you keep defining your codes from the very beginning, from input to output. So input what is your data, because it's very important when you build a solution or you eventually build a recommendation, let's say. So you do need to provide explanation how your solution was obtained. And again, the best way to do it is with R Markdown. I will just show you quickly my screen right now. It's open on my screen right now. When I was given a task in September by my new director, Kaveh, to essentially to develop maybe a solution for data engineering, the first thing I've done, I created R Markdown and I called data engineering in R, and then I started putting everything I found, all packages which I found which were useful for comparing strings, for cleaning text. I found it, I put links there, then all packages for linking fuzzy data. And, again, you could have your own template and eventually you can just knit or compile it and have examples. First, you use their examples, then you use your own examples. So I'm just showing you how I structure my own data engineering process. And we'll be talking about the data engineering is not only about the code itself. It's not only about the result, okay? Good for you. You were able to merge two data sets. No, it's not about that. It's about what is your process? How did you document your knowledge? So I'm showing you how I'm doing that. So for each package I've been investigating, I have my own R Markdown, and my own solution eventually is there as well. Let's go to the next one. Now, this is the third pillar for the work, which is for data engineering, which is interactivity. And that's another tool which is extremely helpful, because when you have data which you can change, you need to make sure that your algorithm works with different types of data. So I will answer myself. I use it, and I do it with Shiny. So Shiny allows you to develop interactive reports and applications. So again, you do not need to do that. There might be other ways of developing interactive things, but I will show you today a few examples. So right here, I have tabs with a number of different, I'm just quickly going, web applications which have been built using all of them using open codes. In fact, my own contribution is really very minor there. One of them is in fact developed by Treasury Board Secretariat, by Open Government Group. They built the code which does topic modeling and natural language processing of ATIP requests. And they put it on GitHub, and I've taken it and I just had to essentially to put it into web application, and then I can test it for different files. I can put it for CBSA, and we can now look into the code, and all codes are available, and we'll talk about that. So I think we are now ready to jump into my the actual PowerPoint presentation. But to conclude this long introduction, the bottom line is we have every Friday we have lunch and learns, I call them, but these are really informal meetups to discuss and show each other what we're doing. So I invite all of you to join, and we can talk more about any of those little tricks I'm doing, and maybe talk about a specific technique which related to, let's say, to text analysis, to sentiment classification. So I created a large repository, for example, for text analysis. In fact, I've done text analysis. You would see here, it's all in this user R. It was about 5 years ago when for the first time I created for myself this on GitLab. I found this tidy text mining book, and it's wonderful book, and we'll quickly go through the content of this book. I think it's the second or third edition now, but I've done it entirely 5 years ago. I've done all of those examples, and you can do it yourself. You can replicate or fork this project from GitHub. And again, by the way, you have to appreciate the fact that this is all written in R Markdown. So when you go to view the source here, I'm showing you, you can just go to tidy text mining and you say fork, or you can code download zip and you extract it, and you have all the examples in this book. Can you imagine? So in fact, you do not need to write even the codes. The codes are all there. You just need to apply them to your own data. In the case of TBS, they applied it to ATIP. And I just had to showcase it to the community and I asked whether they would allow me to do it, and they were more than happy to work collaboratively. That I take their code and I convert it into a Shiny app, and now we have all of that. Another resource which is listed in user R group, topic modeling with R. Again, you can go to GitHub and you will see all the code. It's all there. So right now we're in 2021. It's very different from the way we were coding when I was doing my PhD at University of Alberta. Probably you know that U of A is one of the top 3 universities at AI in Canada. So, and when we were doing it, we were all building those codes ourselves, and regression and neural networks and text recognition, you know, the optical character recognition, OCR. And now it's very, very different. You do not need to develop those codes yourself. What you do need is to create a knowledge base, like repository, where you will update your knowledge using the open source codes. So, and I'll just show you a few examples on how I did it myself, and I'm now trying to essentially to share my experiences or knowledge with the team here. So, problem. We talk about dates. We talked about names, and myself, I'm so much familiar with this problem. Practically no one spells it correctly in English. But in fact, actually, there is no correct way of spelling, because it was originally in Cyrillic, in Ukrainian, and it could be spelled in different ways in English. So business names, many different ways to represent a company, right? And you need to merge this. Geographic names, of course, a very simple one is accents, French. And in fact, if you have time to watch a workshop, the GC Data Conference workshop, we talked a lot about the importance of data cleaning or data engineering to enable trust, public trust in our solutions, because, and also bias. People now talk a lot about bias in AI. And here's a simplest example of bias here. If you don't correctly link French names, you will not have French names, French cities, for example, in COVID data. I have experienced that myself, because COVID data is reported without accents. And when you look into the postal codes, they're with accents. So when you merge them, and if you don't merge correctly, you will suddenly not have any French-speaking, or many French-speaking cities will not be there. So you embed bias, not intentionally, but because of poor data engineering, essentially. And this unfortunately happens unless you're conscious about what you're doing, each step of what you're doing. You may embed this bias in AI. You may have bias towards English speaking, for example, or some other. We'll be talking about some point about female and male. So other examples. All of these are very typical tasks, and you do not need to write the code yourself. That's the point. You might be able to find, actually to use my codes. I have written codes for each of these. So would you like to use them? I will gladly share it with you. And similarly, if you wrote something yourself, maybe you can put it in GC code or GitHub, and we can talk about that, Government of Canada employees are now encouraged to share their code, but they need to get permission from their deputy ministers, from director generals, essentially, to allow to share those codes. And normally, if there is no protected data, if there is no private data, it should not be too difficult. And of course, if it's not about some security, again, issues like we are developing codes to risk assess travelers. So now the problem is very common to many of us. There are hundreds, actually thousands of us working with many data sets, and we have many open candidate data sets. So are we having millions of different codes in our different basements and living rooms or computers? Probably yes, but ideally we should merge our efforts, because the quality of also suffers. We cannot guarantee that our code is actually very robust if we have not had a chance to test it, or it's much better if community has already tested it. So now that's the vision. Build data-driven solution for entire Government of Canada community, but also at the same time build community of practice in such a way that two things. It will leverage public data, and we have plenty of open Canada data. Just yesterday we had a presentation from another GC Connects data auditing group, and they were also using open Canada data, and in R, by the way. So excellent. So we can build those codes and maybe make a repository. And also, of course, we would like to tap into the public knowledge specifically of our global community, which is amazing. It's growing fast, and it's very efficient in providing responses, answers to your questions, in particular in Stack Overflow. I found normally it takes less than 3 hours to get the answer to my question. You can ask any question related to R, or even like machine learning or AI, or I've done also a lot of resource optimization, let's say, or constraint satisfaction, which is another type of AI, not machine learning, but AI which is more than just machine learning. So, and very importantly, we need to aim for a robust, transparent, scalable, reusable, most importantly also documented codes, so they can be reused. Documented doesn't mean they need to be polished. It means you just don't lose all the good information, all the good knowledge which you have acquired yourself while working on the project. I've just shown you quickly my R markdown as I was working on data engineering. And I have the same one for every project. I had a project on avatar detection from multiple sensors. So data is coming from voice, from video, from eye tracking, and we need to detect a person, whether the person is lying or stressed or not stressed. And in the beginning, you always start with a blank page, and then you start doing a lot of research, and you find many good codes for voice processing, for tracking eyes, different packages all in R. And yes, just put it there. Don't worry about how you document it, formatting. It's very important. Just keep it for yourself, and maybe then put it in GC code, and eventually maybe even in GitHub if your Director General allows you to do that. So that's the vision, which it seems to me not only myself, but Treasury Board Secretariat in particular is promoting right now. And also there is a concept of scientific integrity right now, which is about 2 years ago was introduced to the Government of Canada, which means that we have to show diligence in how we come up with our scientific solutions, and also openness. Like by default, all our science is open, so we should really make it transparent to our colleagues. So this brings us to the concept of data engineering as something more than just coding. And in order to define data engineering, I'm looking into the definition of software engineering. So data engineering is a very new term. It's probably less than 5 years. Software engineering is more than 50 years old. There are proceedings, conferences in software engineering, and specifically it is defined as a field which is focused on developing, most importantly, scientific and technological knowledge and methods for implementation, testing, and documentation. And another one, which is from Google, for example, it's programming over time. So you build something today, it's very important. Next year, you can reuse your codes, or someone else can reuse your codes. And you build something, you encapsulated it maybe as a package, maybe as a just a R file, which you will not be touching after you've sort of finished the project. So the data engineering should also be defined. That's essentially my sort of proposal for the community as just the same way. So it's about developing knowledge methods in addition to implementing, but also testing and documentation. And here we'll be talking about some ways of testing, which is interactive testing, and documentation, which is R Markdown. So it's transparent from input to output. Now, vision, two streams. First, development of knowledge. There are two options. One is for government only, and we've started doing it. The other one is it's open to public, but you need to still to have account in GC Collab, and we've started doing it. And the other one is open to public, and you don't need any accounts. And I'm giving you an example. This is a portal on GitHub, which is created by TBS. And you can become a member of this portal as well. So this is where we can start putting our knowledge. Now, development of codes, this is how it could be done. Now, this presentation is focused on R, and for a reason. But it doesn't mean that Python is worse. No, it's not about that. It's about that you can use together R and Python if you want to. And right now you can do it from the same RStudio. So RStudio, you can have one screen, and I have it right now. In fact, actually, I'm right now learning Python a little bit myself because I want to show how you can easily call R from Python, because many of my colleagues work in Python. So in fact, for one of our lunch learns, we would like to dedicate it just entirely to show how you can run all the beautiful R packages, but from Python. But so you develop packages or codes, but then you need to test, and then you need to build end user essential applications. Now, taxonomy, I'll just quickly go, because these are different tasks which I have done, and some of them I would like to do, or maybe invite you to contribute to those. So general text cleaning. So tasks are, I divided them in three groups. One is just you take one variable and it's just simple cleaning, or it could be simple extraction of date, month, and year from a string. Or it could be extracting a postal code. Now there is multivariable. When you have names, for example, with like records with addresses and first name and last name, and they could be misspelled or spelled differently. And then, of course, there are also relation-based, and I will not be talking about that here, but it's the next level of data engineering, because you do need also to take into account how different variables relate to each other. And again, all the knowledge is available in GitHub, for example, or that textbook, which I have a reference in the beginning. So, and the tools, these are 4 tools. So that's how I called this presentation. Now, algorithm. I already mentioned this important joke that there are 3 numbers essentially, right? 1, 2, and infinity. So you need to develop the algorithm which should take any input, and input in your case it's data. It could be, in my case, it was a frame, it could be a video frame, it could be sensor data, for example, eye tracking data, or it was COVID data. So I've done, in fact, just as a hobby project for myself, I've taken this COVID data, and last year we had Lunch and Learns, and we built a web app for visualize COVID data. But COVID data changes every day, and in fact, they also change name variables sometimes. So, so eventually, your algorithm should be robust, and it should take any data and eventually convert it to some meaningful filtered result. So, for the purpose of automation, scaling, and reusing. So if you want your code to be reused even by yourself, let's say in a year from now, you need to write algorithm or definition for it. Now, for algorithm, the result is not important, very important. It's another thing from computer science, introduction to computer science. I don't care as an instructor in computer science what your graph is. It's beautiful, nice. What I need to know, show me the algorithm, like a flow chart it could be, or again, now we have R Markdown. And show me how you've tested your algorithm. So it works not only with, let's say, today's data or only with CBSA data, but it works for all data. And again, Shiny allows us to test it. In fact, another app I've built is for analyzing PSAS results, you know, those public servant employee survey results. And it should work for any department. So I built a code, and now you can visualize for any department. And the same for this Treasury Board ATIP. You can do it for any department. Now, next pillar, R. So R, again, it's becoming right now, historically, it's one of the, probably the fastest growing language right now. So in 1 year, it went from rank 20 to rank 8. And if we think about data science, really we're talking about Python and R. And Python, you know that I did myself Python actually as a hobby project with the Raspberry Pis for robotic projects. So it had nothing to do with data at that time. So Python is a very general language. So, but for data specific problems, R indeed is developed with data in mind. So it has tools to work with data. So visualization and interactivity and R Markdown, it's all about data. And of course, GitHub is embedded now in RStudio. So you can, or Git, you can do it directly from RStudio. Now, R Markdown, I'll already mentioned to you, this is the way you can describe your algorithm from data to result. So it's transparent, it's reproducible. Now, I'm showing you example from this code, which I've taken from GitHub, from TBS. And I had just slightly to rewrite it. And we can talk about, you know, the way you write your code, because as a computer scientist, I've been trained to have proper definitions. So the variables need to be defined, so I know what the variable is. It's a data table. And also I know that the data could be huge. So I need to use such a package which is smart in working with big packages. And data table is one of those. So this is example. And again, don't hesitate later to join us for Lunch and Learns. This is just example of R Markdown. Another one, R Shiny. In fact, you can think of it as R Markdown, but just with the extra line. You run it as a Shiny, and you add here a little slider metric. And here, I will jump straight into demonstration of how this Shiny code actually works. So these links will be available. You'll have time to play with them, with all of them. Now, for the links, the PowerPoint, the deck which I'm presenting will be shared with you. I think it's probably already in GC
I shared it.
Yeah.
In the
so,
chat.
Excellent. So, and just in comments, I put all the links there. So all the links for all these apps, they're all there. So you'll have time, and you'll see how it works. Now, I will just show you example names. For example, we'll be talking about different string metrics. I know that many of you work with the text analysis and you do compare strings. Now there are many different metrics, and at the workshop on February, we talked a lot about those different metrics. And there are metrics based on qgrams, for example, and metrics based, and Jacquard is one of them, based on qgrams. Another one is Jara-Winkler, which is a heuristic. Another one is Soundex, based on phonetics. And if you don't know how it works, the best way, you just play with it. You write a little code, and you see what are the results. So in this case, what I'm doing here, I'm using here this little code which is actually right here. So I'm taking the function string dist from a package which was developed over 10 years ago, and I'm just using different metrics from my slider, and I'm using the distance because I want to know how different metrics, what is the result for different metrics. And now I know that, for example, the metrics are actually very different here. For one metric, it will be the closest. For another metric, actually, so you see, Dmitry will be the closest to Dmitry. By the way, this I'm using open source data set of British names. So as you see, Dmitry is not a typical British name, right? So, but the closest is this one. So Dmitry, or now if I do Winkler, it will be slightly different, and you can see how it works. So you can play with it because it's interactive. You see how important it is. You can actually learn yourself, because if you just apply it blindly, you will see that one metric is working, or maybe it's not working. Maybe it's not the best metric for you. So the best way for you is to learn yourself. And for example, what I found that Soundex, for example, if I do Soundex, it actually it will always take the way it is implemented. It needs to start with letter D. So if it starts with M, then it will not be matched. And because of that, there are other packages. One of them is called phonics. And again, all packages which I have tested and I applied, they're listed in my PowerPoint presentation. And also at the end of actually in here in Info, you will also see different. You'll see here credits and definitions of all those different metrics, definitions of those things. What is good about developing an app like that? Because it stays there forever. And I'll give you another example. So example which I wrote 2 years ago, which is again, it's PSAS result. I wrote it 2 years ago, but it stays there forever. And the same with body weight time prediction and visualization. So I'm just looking at the time right now. We will to the use cases. I'm already introducing you to the record deduplication and linking, which you can test. And actually not only test, but you can actually use it for yourself as well. Now I will show you a little bit web crawling, because this is a good use case when you do need automation. You cannot do web crawling without automation, right? You do need to write the algorithm, which extracts automatically, let's say, dates, or finds nicknames and names variants. So we'll spend a couple of minutes on this use case, and then we'll go to the next use case, which is essentially a project with a TBS on ATIP analysis of text using NLP. Okay, so just quickly here, main steps for record linking. Now, because I know one slide is not enough, and you see I'm not spending too much time on all of my slides, because instead I'm providing you with the link to the GC Collab discussion, and there you will find more libraries and everything. But the key steps, of course, still it's good to refresh this. So you prepare features, you extract what is important for you. Then you have to set constraints, and then you use some similarity metrics and eventually algorithms. They're automated or semi-automated, and then you of course you need to measure the quality somehow. So, and this is what I'm doing here. Okay, so it has loaded. I will just show you quickly how it works. So extracting the date. So here you can type any date you want. For example, here and you see how my text changes here. So text is converted automatically into 3 numbers. And if I type something like that, you see it actually it's still, this is actually very nice. I just by mistake I typed apostrophe and it extracted it. So essentially you resolved already one of the main issues which many of government employees and many people, not only government, because have experience. Now you have a code which automatically extracts 3 numbers. So you can play with this. Now use case, web crawling. So for example, so again, all my codes, I'm not building those codes. Again, it's the times are different, very different in 21st century, right? 2021. I'm just using the codes which were already built and available in GitHub. But I applied them to seek for dates of birth of our prime ministers. So you can select, you can type a name, and again, you don't need to worry how you type it. You can put it, I wonder even if I do it like that. Yeah, actually, it's still doing it. So you can type it in a number of different ways, and it extracts it, and then you can take, let's say, all this line, and you can go back to your date and put it here, and voila, the lines. Oh, so actually he's born in the same year as myself. So nice to know. It's example on how you can automate it. So you can write algorithm which will automatically extract dates of prime ministers. Well, you can put, for example, now if you put names, like for example Dmitry, so you'd see it automatically goes to Wikipedia and finds nicknames and forms and alternative spellings, and then you can use this to build your lookup table, because lookup table still is one of the most powerful ways to merge data when they're not the same. So for business names, for names, you see how many different spellings of Dmitry. So you can do it for other names, like name of my brother, for example, and okay, different names and or related names. So it's fully automated. You can now you wrote it once and you can do it infinite number of times. You see this? I like this joke. I keep repeating it. So now you can test it with more challenging tasks. Like you can actually upload your own data. I'll show you here. It's GC code. You can even actually you can see my GC code. Okay, I need. Okay, so I will show you, and you can use it with your own data, by the way. So again, let me just open. It's a CSV file which has 5 lines, and you see that Charles, for example, spelled sometimes Charles, sometimes Charlie. And of course, when you deduplicate, I click deduplicate here, they should be merged together. And you would see duplicated groups, yes, 3. So it's group, this is the same group, 3 and 3, right? Now you can use different metrics here and different thresholds. You can put different thresholds. Now, because you already are experts, I saw that most of you already really, for many years you are coding. The workshop, which was in February, it was more for everyone. But for yourself, of course, you know that there are many parameters, right? And there are many parameters which you need to play with. And one of them is similarity metric. Another one is decision threshold. And you don't know where to put threshold. So here in interim results, it shows you match results for all your, it compares each variable to each one. So you have 5 lines. In total, you have 25. 25, right? So it compares each line to each line, and it shows you how close they are, right? Using this metric, it sums up all metrics for different variables. Now you can do the next step, which is link. So you can link with another data set. So I'm showing it here. You can open it. I have created this file. And by the way, again, I have not created it myself. I keep repeating it. In fact, this problem has been already done many times by other much more experienced probably people in maybe in coding. So I've just taken a small example which is used in one of the tutorials. So, but this is the second file. It has now first file and second file. So you see first file has 5 lines, second has 4 lines. And again, we have some George is spelled slightly different, address is slightly different because there it's spelled main street and here it's main street. And you can see the results. So the result, you understand as a data scientist, it's it depends on metrics. So I can change metrics, and depending on the metric, it will be, the result will be different. And you can see how it works in here. Again, it matches 5 to 4. And this is the result using Jacquard, which is Q-gram metric. So for example, address, so address first line in the first data set to first line in the second data set. It's similar 75, I don't want to say percent, but it has a score of 75. And by the way, we need to appreciate the fact that even though this technique is called probabilistic linking, it has nothing to do with probabilities, with the theory of probabilities. It's it's just fuzzy way of measuring similarity. So 1 means exact match, 0 means entirely different, and 0.75 is somewhat similar. So indeed, main street is similar to main, right? So you see how it works. And now you can put a threshold here, and you will say accept only those which are over threshold, over threshold. And then you would see the result here. We now have only 6 lines in total. So I'm looking at the time right now. I hope this gives you idea on the power of R Markdown, Shiny. It encourages you to play with this tool. And I will go now to the next example, use case, which is text analysis. And here again, it's one of my favorite topics because I did a lot of, it's one of my hobbies, just playing with text from different languages, also from Russian and English and French. And there's many examples already written in textbooks. I will just show you. So you can just go make, you can fork, you can download the entire zip file, and you'll have all our code there. Now, quickly, what you do here. Normally, you would need to have a thesaurus for synonyms. You will need to remove endings, like for gerund, for endings like verbs. You need to have a file stop words. So all these words which are not meaningful, like articles and they. Then you start counting them. You can just start counting words, all words. One word is unigram, or then you can count pairs of them, or n-grams, like 3 grams. Then you can compute term frequency, inverse document frequency, this concept which defines how prevalent is this word, particularly in this document. And then you can visualize it in a number of different ways. And then you can use a latent Dirichlet allocation, which is a very good technique, again, very well established technique, and I'll just refer people to this page because it provides the codes here. It provides examples here. You can play it with the example, or you can play now with a tip example, or you can play it with your own example. So I'll just show you how it works in Shiny app. So, and you can ask questions there. But essentially, it implements all those text analysis topic modeling steps which are shown in the slide and which are discussed in actually in these two references. This is another very good references for those who, I guess many of you already probably know it. But I found it so this one is recent. The text mining with R is 5 years old at least, and now this one is recent. And again, it defines different techniques and how to visualize the words using Words Cloud and some essentially counts. You start with counts and then with LTA. So what do we have here? We have a Shiny app. Now, is there? I'm just I need. So, John, is there any question? Because right now we're getting closer to sort of to the final.
Yes,
to the final maybe 20 minutes. So essentially here, I will just quickly show you what you can do here. So you can extract topics. I'll just use CBSA here. You can, how many, the words which are most frequently used in a tip. Then you can do the univariate, bivariate, bigram, and bigram analysis. And there are nice packages. One is actually called Topic Modeling R. And it allows you to plot, to group bigrams. You can set how many bigrams in a group. And there are different ways of grouping them. So one of them is by correlation. So the correlation should be more than 0.7. So if it's more than 0.7, you say these two terms are related to each other, and then you plot it. So this is what we see here. So let's say CBSA, agency, services, border. So here is something different. And in bivariate, it's like two terms, and you can, again, you can see by, for example, by year, how many, let's say, different disposition is means it was disclosed, not disclosed, or doesn't exist, and you can see how it changed over years, for example, right? So visually, it's very appealing. So I know many of my colleagues at CBSA work with a tip. But such picture is, as they say, picture is worth a million of words. It tells you right away, you know, what is the essence of all those requests. So maybe that's a good time to open discussion. Again, I'm happy to continue discussion after midi, après-midi aujourd'hui, où aussi encore chaque vendredi on se rencontre à partir de 11h30. So, Jean, to you, if there are any questions, let's start a little discussion.
So Greg asked, do you have Shiny sitting on your tech stack within department firewalls?
No, it's a very good question, and let me refer to you to a related discussion. As you would see, all questions which we're discussing, I will put them in user R because these questions are discussed many times, and this question was discussed. Now open codes in here, so that's the one which is, I think, oh, sorry, it's not in this one. It's in this one. So the answer is all these apps, all these which are shown here, they are all of them on shinyapps.io. This is our studio-owned portal. It's free. you can host, you can just create account. So I created a bunch of accounts, like one is called iTrack, one is called R Canada, and it's free. Now, my directors essentially encouraged me to explore all these open tools, but again, it is assumed that we are not putting there any CBSA data or any protected data or any personal data. So everything which is used in all these 4 applications, or all those which are used in my reference in my slide, all of them I'll just quickly go to. Yeah, so all these use cases, all of them are using open data. It's very important. Again, it's very important to understand. So you cannot use Shiny apps if you're using with a private or protected data. So all of this is more to demonstrate the technology, or maybe to develop a final app like this demo app, which allows you to merge your data. But to answer your question, let me go now to this discussion, which we had at some point. Shiny. Okay, so that's a discussion. And essentially, there are 3 options here currently. We used all 3 of these. So in CBSA, we do have our internal network, which is not connected to anything. But in order to transfer your protected data or other data into network, you do need to use some iron key, some protected hard drives, and you can run your Shiny server there. So that's this option. So that's what we have in CBSA in some departments. Now, it's you have full Shiny functionality, but you cannot really run it. You cannot easily show it, let's say. Now, we use other type of interactivity. For example, for communicating our results, we use Plotly, we use data table, and this currently is the most used technique which we're developing for our clients. So I have done many reports analyzing the performance of biometric systems in our airports. So all of them are interactive, because otherwise you have all those many kiosks, all those airports, but with a data table and with Plotly, it becomes very nice, right? And many of you already are familiar with it. So no, you cannot email Shiny, but you can use Plotly or data table. Now, what I have also Shiny running on my local laptop, and I would invite my colleagues to come over to my laptop and watch it. So I would say this is a very good question. I would like to keep this discussion going. I'm sure there are people more knowledgeable than myself on how to enable it within government. So it also within government protected B environment, because many of us work with protected B environment. So I hope this answers at least partially this question. Any other questions, John?
Yeah, so if you want to further discuss that, you can definitely go on the GC collab that Dmitry has over there. So Christian asked clarification on the earlier link you shared about NLP and R, something with skeletal github.io.
GitHub.
Or Christian, if you're here, you can explain further.
Or is it so? Is it specifically for Treasury Board application or for NLP?
For NLP, thank you, Dmitry. I didn't note down the link to the website.
It was in the earlier of the presentation.
Well, okay. I know. Okay, I guess I know what you're talking about. Probably the actual code, maybe this one.
Yeah.
So this, okay. That's, and by the way,
Great help.
So there are many codes already developed for Open Canada data. And again, I will show you a resource which I started building actually a couple of years ago, but then it has become not only for myself, but for many people. So again, it's this portal, and here the best way, okay, so resources, so here it's learning resources to teach yourself, but also if you go to GitHub, there you would see these are GitHub for Canada. And there you would see many packages and repositories which have already nice codes to process many data sets. Even more, on top of that, also I have forked in this, so I just created this portal in the beginning for myself, but now I'm talking with the Treasury Board folks, and the idea is to actually to transfer this type of activity to their portal. Actually, they have two portals. They have open data. I hope you can see it, and the other one is Canada CA. So that's where they you can become a member of this group, and this is where also they have a collection of repositories and codes for Open Canada data. Now here you will see many, actually many packages which I have just forked. You know, I'm not actually editing them, but as a knowledge base, as to keep growing my knowledge base and to share it with the community. Oh, and here, by the way, is also this one, so which is Treasury Board. You can, and many other, you know, many other things which are here. So I hope I answered this question. Anything else, Jean?
No, there weren't any other questions apart from that. If anyone has any questions, you can post them in the chat or use the raise hand option in MS Teams. In the meanwhile, Dmitry, if you want to comment on anything else, last things, you can feel free to do so.
Okay. So I think we have not done this slider. If people are still using slider, essentially now you know which user are GC Collab group. By the way, I'm not even sure this is the best the best technique to maintain, because maybe wiki.collab.ca could be a better one, because really I'm not sure. So again, I'm learning here all the time, and I'm saying here, the more I learn, the more I know how much is still which I would like to learn. So if you have any ideas on how to better arrange our this user R group, please let me know. And just the final slide here, because the final slide is right here. So okay, you know now how you can help. Join us for Friday meetups. Contact me. Now I have to also to say that I am kind of in a unique situation in CBSA, because actually my position is called research scientist. So I'm RES, not EC as most of my colleagues. So RES, it gives me kind of a larger mandate. It gives me a mandate to do literature review, to collaborate, to seek for best solutions, you know, like to optimize, like really to what research is for, really, to optimize, to improve, to be proactive, and to find the best possible, most up-to-date techniques. So that's why I was given this task eventually to lead this maybe not to lead community, but to help to organize these community events such as Lunch and Learn, and develop this app and present at the conference. So contact me any way you wish. Also, of course, I'm sure you have your own challenges, and thank you for sharing those. in the beginning of our slide interaction. I know many of you already have processed some open candidate data sets. So why not we can all put them there. So that pretty much concludes my presentation. And here, I guess many of you already have seen this slide, and I really loved it. It was so timely. Like, I'm joking again that as if someone on the internet cloud was listening to my, that I was preparing for this presentation and send me on LinkedIn this beautiful slide, because this data engineering work is tough. It's like 75, it's like 100% of our time, or 90% for many of us, so that finally you can do an easy job. Like, easy, I mean, it's not easy. Of course, you do need still to have the knowledge of all those very sophisticated techniques. But if you already know how to use GitHub, you will be able to replicate those techniques easily, instead of developing those wheels yourself. Now, here you also see the list of packages, and more of those are listed in the actual in the comments of my PowerPoint. So here, I just show you in appendices. You can look at your own time examples on those different visualizations or results which you can get with the slide and those two applications which I was showing. So thank you for participating. I think we're done. At least on my part, I think we are done.
Okay, sounds good. So please visit the user R collab, GC collab that Dmitry made. Our slides are available in our GC Connects page, so you can check that out. I put the link in the chat, but once you leave the this meeting, you won't be able to access the chat, so please save it now. We don't have a presenter for April yet, so if you are interested in presenting your work or putting out questions for discussion between practitioners in this meeting, please email me. You have my email in the Outlook meeting invite, but you can also put it in the GC Connects discussion page as well. If you don't have any other questions, then I'll see you guys in April.
Okay, so thank you everyone, and look forward to talk to you again.